All right, so we're in the Unit 9 review. Make sure you have it out if you're watching this video because we're going to work through it. Number 1, given Pentagon Pqrst inscribed in a circle, find the measure of arc QR. All right, so we're looking at finding the measure of this piece right here. Well, we know that since all of our chords are congruent, we know that congruent chords have congruent arcs. So each of these pieces of my circle are all going to be congruent. Each piece makes up my whole circle, and I have 5 little pieces. So I can do 360 divided by 5. So I know each of my congruent arcs is 72 degrees. For arc QTS means I start at point Q, go through point T, and end up at point S. Well, how many of our congruent arcs was that? So each of these pieces were 72. Well, there are 3 of them. 72 times 3 gives us that our QTS is 216 degrees. Number 2, using the diagram below. All right, well, we have 2 chords that are both equidistant from the center of the circle. So we know our chords are congruent since they're both equidistant from the center. So since this one's 15, this one has to be 15. They're both 15. Number 3. In circle E, OP equals SH. Here's OP. It's congruent to SH. And EY is 7. Well, since our chords are congruent, it means they have to be equidistant from the center. And since EY is 7, we know EL has to be 7. Number 4, find X. We know that our tangent line is perpendicular to the radius at the point of tangency. So we know that's a right angle where our radius hits our tangent line at the point of tangency. Well then, we're looking for X. X is our hypotenuse. So X would be 5 squared plus 15 squared equals X squared. That's 25 plus 225 equals X squared. So 250 equals X squared. X squared, take the square root of both sides. We get that X equals 15.811. We're not done yet though, because we also have to figure out Y. Here's angle Y. Here's where our person goes. If we're looking, and I told my classes that I would use, even though we have all 3 sides since we found X, I would use the 2 sides that you were given in case something went wrong and you got X wrong, then you don't get the rest of the problem wrong. So I know 5 is my opposite, 15 is my adjacent, so that means I know I'm using tangent. I know tangent of Y equals 5 over 15. Because I'm looking for the angle, I have to use the inverse. So Y is the tangent inverse of 5 over 15. Plugging that in, making sure we are in degree mode, we get 18.434 degrees. All right, so then now we are done with problem 4. We can move on to problem 5. Given a circle with a radius of 8 inscribed in a square, find X. Well, I know the whole line would be 16, which means this bottom side would be 16, and since it's a square, all of my sides are going to be 16 inches. Number 6. I have 2 tangent lines. And back, 2 segments that are tangent to a circle from a single point outside of the circle, like we have here. Our single point. We have 2 lines that are tangent. Means these are congruent. So X is 15 meters. Number 7. We have a circle. We have 2 90-degree angles. And we know that these are 90 degrees also, because this line right here is tangent. Here's a radius, tangent, radius. We have 4 90-degree angles. So, since this is C, this is 11. This is also another radius. This would be 11. We have a square, so x is 11 centimeters. Number 8, more trig and Pythagorean theorem. All right, I'm going to do y first, and I'll come back to it for x. With y, here's my little person. So my opposite is 10, my adjacent is 4. So I'm using tangent. Since I'm looking for the angle, I know I have to be using my inverse. When I plug this into the calculator, I get that y equals 68.198 degrees. Apologize for the jumping. All right, so for x. With x, I'm just looking for this little part that I've outlined in green. To make it a little easier, though, I'm going to look at this whole line. I'm going to call this C, because it's my hypotenuse, because this is the right angle. So I know 4 squared plus 10 squared would have to equal C squared. 16 plus 100 equals C squared. 116 equals C squared. Square root both sides, I get that C equals 10.770. All right, so let's look at C. We're just looking for the green part. Well, this part that I've outlined in blue, we know that's 4 because it's a radius. So the green would be my whole line minus 4. So I'm going to get x is 6.700 feet. Awesome. Number 9. All right, be careful here. I know some people in my class, we put, we're a bit confused thinking where our right angle is. Make sure your tangent is perpendicular to your radius. Here's your tangent. Here's your radius. So there's a right angle. And also here's a right angle. Let's see what we know. We know that CD is 12, which means our hypotenuse is going to be 12. We know CF is 7, which means we would also know that CE is 7, because it's another radius. And then we're looking for ED. We're looking for X. So X is my hypotenuse. No, X is not my hypotenuse. X is one of my legs. Sorry. 12 is my hypotenuse. So 12 squared equals 7 squared plus X squared. 144 equals 49 plus X squared. Subtract my 49. I get X squared equals 95. And I just have to square that. I get X equals 9.746, and we're in feet. So ED is 9.746 feet. All right, next page. Number 10. All right, so let's look at this. Since we know YZ is 18, we know YA is going to be 18 because it's another radius. We know angle YZB is going to be 90 degrees because we have a radius intersecting the tangent line at the point of tangency. So we look here. My hypotenuse of this triangle would be this whole line. So my hypotenuse is YZ, which can be 18 plus 9, which is 27. So then when I set Pythagorean theorem, I need 18 squared plus b squared equals 27 squared. 18 squared is 324. plus b squared equals 729. Subtract the 324 from both sides. So I get b squared equals 405. I'll square root that, b equals 20.1424 yards. All right, number 11. We're going to use our old tangents, true tangents that intersect outside of a circle are congruent. So that means I know both of these are 2 centimeters. Since this from here to from the point of tangency to the corner of my triangle is 4, I know this one's also 4 because it's just to the same point. And then since I know that from here to here is 6, I know that this part is 6 also. So x is just 6 plus 4, which is 10, and my units are centimeters. Number 12. I'm the same kind of thing, paying attention to my sides. So I know that DA is 6, which means FA is 6. So here I can cross off anything that has AF as 2. And I have FC is 2, so EC would also be 2. Both of us have EC is 2. So then, since EB is 7, BD would also be 7, which means my answer would have to be C. Number 13, I'm trying to find the perimeter of this. Well, here, FB is 10, so I know that EB is also 10. And since BA is 16, it means EA has to be 6, which leaves BD having to be 6. And then since DC is 8, CF is also 8. And then I just add all that up. 10 plus 10 plus 6 plus 6 plus 8 plus 8 gives me 48. All right, 14. I have my intersecting segments. This one is 2 secants, so I know my formula is ow equals ow. If I look at my top line, the one I'm just outlining in red, my outside part is 8, so I know I have 8 times. My whole entire line is 8 plus 6, so my whole thing is 14. And then I look at my other secant, which I have outlined in green. My outside part is 4. My whole thing is x plus 4. So then I have to do some math. 8 times 14 is 112 equals 4x plus 16. Subtract the 16. I get 96 equals 4x divided by 4. So x has to be 24. All right, so let me keep going. Now we have number 15. I'm going to label my stuff. So I have the ED is x plus 2. AB is 8. BC is 12. And DC is also 8. So again, I have 2 secants. So my formula is ow equals ow. Looking at my top line, my outside part is 12. My whole line is 20. And that equals my outside part of my blue line is 8. Now the whole thing is 8 plus the x plus 2. So I have some combining in there I need to do. 12 times 20 is 240. And this equals 8 times 10 plus x combined by 8 plus 2. So 240 equals 80 plus 8x. And then I subtract. So I get 160 equals 8x. Divide by 8. I get that x is 20. Then I'm looking for EC, so I need to figure out this whole line. X is 20, so I plug it in. 20 plus 2 plus 8. That gives me that EC is 30. All right, so we move on to the next page. All right, so this one, we do not actually have to solve it. We just have to write the equation. So this is another ow equals ow. So our top line, our outside this time is the x. So we have x, and the whole thing, we have to add the two together. So our whole thing is x plus 8. Then on our bottom secant, our outside is 5. So this equals 5 times whole line, add the two together. So 5 times 15. So we used the x, 5 equals plus 8, 15. And there we go. That's all we have to do for that one. Number 17, now we have two intersecting chords. So this is our A times B equals C times D. All right, so we look at this, what we got. A and B come from the same line, so I can say here's A. 4 is B. A and B, they both come from the same line. And then C and D also come from the other line. So I can say 6 is C, and then X is D. So then I have to do this math. 8 times 4 is 32, equals 6x. Divide by 6. I get that x equals 5.333. And there's my answer. Next one, I have two chords. I'm going to label what I got. This one right here is 2x minus 1. EB is x plus 3. EC is 9, and AE is 5. So again, I'm at my AB equals C times D. So I pick one of my chords. Here's my one I'm picking. So A and B would be x plus 3 times 9. And that would equal, when you look at this line, that equals 5 times 2x minus 1. So we have some distributing and then combining terms. So I get 9x plus 27 equals 10x minus 5. Subtract the 9x. Both sides, I get 27 equals x minus 5. Add 5 to both sides. I get that x equals 32. So then, since x is 32 and I have to find AD, well, AD is 5 plus 2 times x, which is 32, minus 1. 5 plus 64 minus 1, so that's 69 minus 1, so AD is 68. All right, 19, I have a tangent and a secant. Look at my secant first. Here's my secant. This is outer times the whole equals our tangent squared. So for our secant, our outer is 6. Our whole thing is x plus 6. And this equals our tangent squared, so equals 8 squared. So this is 6x plus 36 equals 8 squared, which is 64. Subtract the 36. Get 6x equals 28. Divide by 6. And I get that x equals 4.666. All right, so then we get to the next page. Number 20, we have another secant time in our tangent, intersecting secant and tangent. So this is L equals our tangent squared. So our outside is 6. Our whole thing is 6 plus 9, which is 15. And this equals x squared. And don't be afraid, because this one doesn't require any quadratics. 6 times 15 is 90 equals x squared. Since we don't have a regular x term, we can just take the square root of both sides. So that would be 9.486 equals x. And there we have it. All right, the equation of the circle. We know our general form is x minus h squared plus y minus k squared equals r squared. So our h is 3, our k is 8, and r is 6. So we need to find one that has x minus 3. So we can automatically cancel out c and d. And then a and b are similar, just one has r squared. Since we need the r squared, our answer is b. All right, so now we are looking at identifying the circle, the center, the radius, and the diameter. For A, since we didn't add anything to x or y, we know our center is 0, 0. And then our radius, just do the square root of what you got there. Square root of 36 is 6. Diameter is 2 times our radius, so that would be 12. Next, for part B, since both our h, since we have x minus 1 and then y minus 3, we know h and k are both positive. So that's the point. 1, 3. Our radius is the square root of 9, which is 3. And then 2 times 3 is 6. Next one, we have x plus 8. So we know our h was a negative, with negative 8. And y minus 3. So we know our y value, our k, was positive. Our radius is going to be the square root of 20, which as a decimal is 4.472. You left it that way. If you left it as the square root of 20, that was fine. If you left it as square root of 20, your diameter then is 2 times the square root of 20. And if you have the decimal, your diameter is 8.944. All right, so we're going to write the standard equation of a circle given the center is 3, negative 5, and a point 0, negative 5 is on the circle. I'm going to graph this. I'm going to make up a grid. 1, 2, 3, 1, 2, 3, 4, 5. So I have the point 3, negative 5, and 0, negative 5. Well, guess what? It's on a straight line, so I can just count over. 1, 2, 3. So that means my radius is 3. Because I didn't go up or down at all. So I can just count over. And then squaring that, and so I went over 3. So my equation, x minus 3 squared plus y minus negative 5 squared equals 3 squared. And then just to make this a little nicer, my x minus 3 squared stays the same. Y minus a negative 5 turns into a y plus 5. And then 3 squared is 9. So there's our equation. All right. So the next one, we have to write the standard equation of the circle given that 2, 6, and 4, negative 2 are the endpoints of the diameter. So I draw my makeshift grid. Remember, you guys can ask for graph paper. We all have some. Here's my point 2, 6. Here's my point 4, negative 2. Find my midpoint first. So I have x1 plus x2 over 2, y1 plus y2 over 2. Some of this is 2 plus 4 over 2, 6 plus negative 2 over 2. I do all this, I get the point 3, 2. So there's my center here at point 3, 2. So I'm just going to start writing my equation. I can know it's x minus 3 squared plus y minus 2 squared. And then I'm going to use my center point to figure out the distance of my radius, because then I just have to find that and I don't need to do any dividing. I went down 1, 2, 3, 4. Again, this will be nicer when you have the graph paper, not just my makeshift graph. So that's down 4 and then over 1. Yes. So my radius would then be the square root of 4 squared plus 1 squared, square root of 16 plus 1, which is the square root of 17. So r squared is the square root of 17 squared, so r squared is simply 17. So there's my equation. Next problem. All right, I have to write the standard equation of the graph written below. All right, well, I'm going to look at here my diameter. Here's my diameter. That looks like it has a distance of 1, 2, 3, 4, 5, 6, 7, 8. So I know my radius is 4, which puts my center at this point right here, which is the point 2, 2. So when I have the graph, it makes my writing equation super easy. X minus 2 squared plus y minus 2 squared equals 4 squared, which is 16. And there's my equation. All right, I know that A is my center. So A has the coordinates 1, 2, 3, 4, 5, negative 3. So I can start off with writing my x minus 5 squared plus y plus 3 squared. This equals, got to figure out my radius. So I have to go down 1, 2, 3, 4, 5. Over 1, 2, 3, 4, 5, 6, 7, 8. Yes. This is 8. So 8 squared. So then my radius is the square root of 25 plus 64, which is the square root of 89. And then when I square that, r squared is the square root of 89 squared, which is simply 89. There's my equation. All right. So I'm given that the circumference is 24 pi. Well, I know my formula for circumference is 2 pi r. So figure out my radius. Circumference is 24 pi, and that's equal to 2 pi r divided by 2 pi. My pi's will cancel. 24 divided by 2 is 12, so r is 12. My center is the origin, which is the point 0, 0. So my equation would be x squared plus y squared equals r squared, which is 144. There's my equation. Next one. Given the standard equation, x minus 5 squared plus y plus 6 squared equals 36, is the point 4 and negative 3 on the circle? All we have to do is plug in the points. Our x value is 4, so we have x, which is 4, minus 5 squared plus negative 3 plus 6 squared. We want to see, does that equal 36? Well, let's look. 4 minus 5 is negative 1 squared plus negative 3 plus 6 is 3. We just square that. Negative 1 squared is 1. 3 squared is 9. So this is 10. Since 10 does not equal 36, this is not on our circle. This is not a point on the circle. Next page. All right. Given the center is 8, negative 2, and the radius is 6, we'll figure out some possible points. So think about it. Here's the point 8, -2. Means I need to go, I can go 8, I can go 6 this way, I can go 6 up, I can go 6 to the left, and I can go 6 down. So to figure out my points, I can take x, I can either add 6 or I can subtract 6, which will give me either the point 14, -2, or 2, -2. Oh, hey, looky there. 14, -2 is one of our answers. So I already got it. So I could stop, but let's make sure we know how to get some more points on this circle. Our radius is still 6. Here, I just changed my x value. I can also go up and down, though, which changes my y. So my y, I could take -2 and go up 6, which would take me to the point of 8, 4. Or I could go from -2 and go down 6. So I can subtract 6, which would take me to the point 8, -8. All right, so using that, I have my center, which is the point 3, 1, which is here plotted here at C. I have a radius of 6. So my possible answers, remember, you only need 1. I'm going to put like 3 or 4 of them down, depending on the space on my graph. I could go 3 up. I could go 6 up. So here's one example for point D. I could go 6 to the side. There's another point D, or I could go 6 down. I also could go 6 to the other side, but then I'd end up off my graph, and who really wants that? All right. Number 31. All right, circle O is defined by the equation x plus 5 squared plus y minus 3 squared equals 36. Plot the center of the circle. Well, I have that. I just need to take it out from my equation. Since I had x plus 5, I know my center will be -5, 3. Looking at my two parentheses. So I plot that, -5, 3. Here's my center. I'm going to label that O because it says circle O. And then I know that r squared is 36, so my radius is 6. So then a couple points that are on my circle. I'm going to draw a couple. You only need 1. I could go over 6. If I go down 6, I'm off the graph. If I go the other way 6, I'm off the graph. I could go up 6. So either one of those points would work. You don't need both of them. You only need 1. Next one. All right, so I know that I have circle O with the diameter CD, so I need to find my midpoint, find my center. I'm going to graph my points. All right, so my midpoint. I'm going to do -3 plus 5 divided by 2, and then 0 plus -4 divided by 2. I just on the calculator, I get 2 over 2 and -4 over 2. So this is the point. So my center is at 1, -2. So I know I'm x minus 1 squared plus y plus 2 squared. So x minus 1 squared, y plus 2 squared. My radius. I have to go to get to my, I'm going to plot my center. Is at the point 1, -2, right there. So to get from my center to one of my points, I had to go down 2 over 4. So that's 2 squared plus 4 squared. So that's 4 plus 16, which is the square root of 20. So when I square that, get my radius squared, I just get 20. So it's all equals 20. There's my equation. Next page. All right, this one requires some logic because you need to remember the relationship between sides and some of your Pythagorean triples. Looking at your numbers up there, we have a couple different, we have 2 Pythagorean triples. We know 3, 4, 5 is a Pythagorean triple, but if we got used 3, 4, 5, then 5 would be our hypotenuse, which would mean AE would either have to be 3 or 4. But since we don't, and then AD would have to be double that, but we don't have 6 or 8, so we know it's not 3 or 4. Another one of our Pythagorean triples is 5, 12, 13. Well, then that would make 13 our hypotenuse because it's the longest side. And as to our legs, we could either have 5 or 12 as our legs. But remember, AE, 2 times AE would equal AD. So AE would have to be 5 because we don't have what 12 times 2 is. So AE is 5, EB would be 12, and AD would be 10. We move down, we can figure out what the length of CE is. All right, so we know EB is 15. We know AE is 8. Well, CE is part of CB, which is a radius. So I'm going to figure out the length of my radius first, because that's probably going to be helpful. And I can use my my right triangle AEB to solve that. I'm looking for x, which is my hypotenuse. So I have 8 squared plus 15 squared equals x squared. 64 plus 225 equals x squared. So this is 289 equals x squared. If I take square both sides, x is 17. So now my radius is 17. Well, CB is a radius. I'm going to outline this in red. CB is a radius. So since CB has to be 17, and it's CE plus 15, and that means CE would have to be 2, because I only need 2 more units to make my 17 unit radius. All right, and we keep on going. Number 35. 35. Well, to figure out y, I'm going to do y first, because I don't want to do trig yet. I know the bottom of this triangle has to be 15. So y would be y squared equals 15 squared plus 7 squared. So y squared equals 225 plus 49. This is 274, I believe. Just give me 1 second to double check that. Yes, equals 274. And then square root that. So y is 16.552 feet. And then to figure out x, I have to use trig. And I think I mentioned this earlier in the video, but whenever I'm trying to find an angle, I use the size I was given in case something went wrong and I got my side I searched for wrong. So I'm going to use my 15 and my 7. So here's my triangle I'm looking at. Here's my x, 7 and 15, which makes 7 my opposite. 15 is my adjacent. So the tangent of x is 7 over 15, which means that x would be tangent inverse of 7 over 15. So then I get tangent second 15. X is 25.016 degrees. 36 is very similar to 35. I know that this length is 4 because it's half of that chord. AC is a radius, so it's 7. So to figure out y, I have 7 squared equals 4 squared plus y squared. 49 equals 16 plus y squared. Subtract the 16. Y squared equals 33. Square root both sides. Y equals 5.744 centimeters, and I apologize again for the jumping. Then I need to find angle x. I'm going to use my 7 and my 4. 4 is my adjacent, 7 is my hypotenuse, which means I know I'm using cosine. X equals 4 over 7, so x is the cosine inverse of 4 over 7. Cosine 4 over 7. So x is 55.150 degrees. Perfect. All right. Number 37. We are almost done. We have about 5 questions left. 37. Oh, and this one's the fun one. We have an ow equals an ow. So we look. Our outside of our top secant is x. Our whole thing is x plus 2. The bottom secant, our outside is 4. Our whole thing is 12. So we have x squared plus 2x equals 48. I need to make this equation equal 0 since I have no like terms to move around and combine, which means I'm going to factor this. So I set up the box. I need two numbers that are going to add to 2 and multiply to negative 48. Well, I know 8 and 6 multiply to 48, and since I need this to be positive, I need my 8 to be positive, my 6 to be negative. So I fill in my table, 8 squared, or x squared, 8x, negative 6x. My common factor across my top row, x squared and 8x, they both have an x. X squared and negative 6x, they both have an x. X times what gives me negative 6x? Well, that's my number in front of it, so that's negative 6. And then x times 8x, or x times what gives me 8x, and that's positive 8. So my two factors are x minus 6 and x plus 8. This will equal 0. To solve it, I've set both pieces equal to 0. So I have to add 6. And then subtract 8. My negative answer doesn't make any sense because I can't have a negative distance. So my answer has to be x equals 6. We got another one with quadratics. Making sure we're remembering our factoring. So another ow equals ow. So the top one, our outside is x. Our whole thing is x plus 6. Our bottom one, our outside is 2. Our whole thing is 2 plus 18, which is 20. So I get x squared plus 6x equals 40. Subtract the 40 to get equal to 0. X squared plus 6x minus 40 equals 0. I set up my box. X squared. I need two numbers that add to 6 multiply to negative 40. Well, that would be 10 and negative 4. So 10x and negative 4x. Remember, it does not matter the order you put those in your boxes as long as 10 and negative 4 are in your diagonal. So then, x squared and 10x, my greatest common factor is x. X squared and negative 4x, my greatest common factor is x. I need to figure out what times x gives me a negative 4x. Well, as we're noticing, since our coefficient in front of the x squared is just 1, it's always going to be that number in front of your x. Then, x times what gives me 10? X. Well, that's positive 10. So my two factors are x plus 10 and x minus 4 equals 0. Set both pieces equal to 0. Add 4. I get x equals 4. That's positive. So I know that's going to be my answer. Just double check the other one gives you a negative, which it does. So my answer is x equals 4. And now we get to everyone's favorite things after quadratics, constructions. To construct my circle inscribed in my triangle, I have to construct two angle bisectors. So I need to go up and find my compass. There it is. Remember, yours will be neater because you have a straight edge, and I am still yet to be able to figure out how to turn my ruler. So I open it up a little bit. I draw an arc. Then I move my compass point over to where my arc intersects my angle. I draw an arc. Move my compass up to the other spot where my arc intersected my angle and draw another arc. Where those two arcs intersected, I connect a line through those 2 points. Continuity's sake, I'm going to make sure it's purple. So there's my one angle bisector. Then I need to go back and do the same angle bisector construction to another one of my angles. I'm going to come down here and do it. My compass, open it up a little bit, draw my arc. Move my compass to where my arc intersected my angle, draw my arc. Bring it down so I can draw the other arc also. There's my arc. Move compass out of the way. Make it yellow. There's my angle bisector. Where those two angles intersect, oops, where those two lines intersected, I put my compass. Then I turn it. I'm going to make it perpendicular with my side. Pick my straight side so it's a little easier. Okay, so there's my compass setting on my, and I draw my circle. And it might not be exactly perfect, but there's our circle. So then we go to the next construction. I need to construct the center of my circle. For this one, I need to first construct two non-parallel chords. So I draw 2 lines in. I'll be school spirited. I'll make these 2 OP colors. There's one chord. Oops, I changed that color. Here's another non-parallel chord that I need to move over so it actually is actually a chord in its truest in the definition of a chord. There we go. So now I need to construct a perpendicular bisector of both of those chords. So I get my compass back. As my compass started out blue, I'm going to do my blue one first. Put it on the where my chord meets my circle. Open it up so it's more than halfway. And I draw an arc. I move my compass to the other edge of my circle. Yeah. And readjust my compass. And draw my arc. Where those 2 arcs intersect, that is my perpendicular bisector. So there's my perpendicular bisector, the blue arc, the blue chord. Now it's going to do my yellow chord. So I draw my arc more than halfway, bring my compass down, draw my arc the other one, and then I need to draw in my line. And I need to move it over. There's my perpendicular bisector there. So the center is where my 2 perpendicular bisectors intersect, right there. Last construction. I'm bringing my compass with me. All right. So my first step is I have to connect my point, center of my circle, to the point that I'm given. I'm just going to draw this in because sake of time. You guys will be using a ruler, so this would look nice and straight. Then construct my perpendicular bisector. Remember, I'm going to be constructing an inscribed angle of 90 degrees. So I draw my arc to start my perpendicular bisector. Draw my other arc. Move my compass. There's my perpendicular bisector. From there, I need to draw a circle, so where those two lines intersect. I'm putting my compass point. And I'm bringing my compass in so it hits my other point. There we go. And I draw my circle. All right. So now, from where my compass, or my new circle, intersected my original circle, here's one of them, and then to my point off my circle, I take my ruler, and I connect those points. There's my tangent line. Because think about it, what we really did, we constructed, here's our inscribed angle of 90 degrees. And we're done. If you have any questions, go back and watch what part you were confused at. And then if you still have questions, ask your teacher. Good luck studying and good luck on your assessment.